My greetings to one and all. Myself Ruhani Barua, a fellow 10th grader for Practical School Bias. Today I would be explaining the working of a self-made optical probe to study the laws of reflection and refraction for Ramana Awards 2023. So first of all, we are going to start with studying the laws of refraction. Refraction basically refers to bending of light due to a change in media. Over here, we have a second media, which is a glass slab, in comparison to the first media, which is air. Here, we have a light for a laser, and when we pass it through it, we can see that it goes from here, so when we turn on the laser, we see that the light goes from here. This is like 1, 10, 20, 30, 40, 50, 60. 60 degrees till here, which is 10, 20, 30, 40 and 45. So when we do the calculations, we get that sine 60 upon sine 45. Now, sine 60 is equal to root 3 upon 2 divided by 1 upon root 2. When we calculate it, we get root 3 upon root 2, which is equal to 1.5. So this is the refractive index for this particular glass slab. If we do any other angles, we would get the same number, 1.5. So now we are going to start with the law of reflection, that the angle of incidence, the angle of reflection and the point of normal lie on the same point of incidence on the same plane. So when we turn it on, so this is a mirror and I have placed it over this platform right here. So this would provide us with a reflective surface. When we turn on this laser, we get to see that the path of light goes from this angle at that's 50 degrees and is visible at, so this is 10, 20, 30, 40 and 50 degrees. We pass it from here, it reflects from here and lands here. 10, 20, 30, 40, 50 degrees. So what we conclude is that the angle of reflection and the angle of incidence are equal. So to conclude, we could say that this self-made optical probe can help us study further with ease and comfortable with economy, and the estimate value is also very low, to study the laws of reflection and refraction in a very simple and enthusiastic way. This is a project for Raman Awards 2023. The statement that we are trying to prove is that when we put an object at the center of curvature of a concave lens mirror, the image formed is also at the center of curvature of the said concave mirror. So over here we have an object, as you can see through the peephole. When we remove the object, the image formed is still there. How is it possible? So this is possible because when we see it, this is a concave mirror. An object is kept beneath this platform. When we remove this object, which was originally over here, the light is parallel and goes from the focal length over here, and the object is still formed at the center of curvature. This is proved by the reflection of light. Thank you. I hope you like the object and the project. Thank you.